Hello, this is Mrs. Scarpel, and in this video I am going to review solving multi-step equations and literal equations. So the thing you want to keep in mind is the process of solving is undoing. You want to undo the equation. So you might want to take a look at the initial expression that we have that has x in it that we're solving for, and think about what is the last thing that I would do if I were to simplify this and it were all numbers, including where the x is at, if it were all numbers. The last thing I would do in this case is the divide by 5. So that's going to be the first thing I undo. If I want to think about the first thing that's happening to x, that would be taking it times 3, then I'm adding 2, and then I divide by 5. So again, that divide by 5 is the first thing I want to undo. Well, the inverse operation of division is multiplication. So I'm going to multiply each side of this equation times 5. When I do that, the 5 cancels the division of 5, and I'm left with 3x plus 2 equals 35. Let's take a look at that expression now. Again, if everything were numbers, I would multiply the 3 with the x first and then add 2. So the adding 2 is the next thing I want to undo. And that gives me 3x equals 33. Now don't confuse 3x as being 3 plus x. 3x means 3 times x. So to undo the multiplication, we're going to divide by 3. And that gives us a solution of x equals 11. Now number 2 is a literal equation because it has 2 variables in it, has more than one. But our goal is still the same. We want to isolate the x. We want to solve for the x. If I look at number 2 and I go back and I look at number 1, the only difference on number 2 is that the 2 is being multiplied with a y. Well, we don't need to separate the 2 from the y, so we can always think of this as being one value. And because it is set up as a 3 times x plus some number divided by 5, I'm going to solve this using the same undo process that I did on number 1. So I'm going to start by multiplying by 5 on both sides, so that cancels that division, leaving us with 3x plus 2y, and I'm going to put a box around that 2y just to help us remember that that's actually one value. And the y isn't what I'm trying to isolate. And 7 times 5 is 35. So 3 times x, that's the first thing that's happening to x, plus the 2y. So I want to undo that addition by subtracting 2y on each side. Now, unlike number 1, I can't take and subtract 2 from 35 because this is a term that is 2 times y. That's a different term than the constant 35. So what I'm going to write is that I have 3x equals 35 minus 2y. And then the 3 times y, remember this is a multiplication, we undo by dividing, and we divide that entire expression, 35 minus 2y, by 3. So we now have a solution of x equals 35 minus 2y, all of that divided by 3. Now, if 35 and 2 were multiples of 3, I would simplify this further, but they aren't, so this is my final answer. Let's take a look at number 3. 4 times x is the first thing that's happening to x. And then dividing by 3 is the second thing. And then subtract 5 is the third thing before we get equals 11. So this subtract 5 is the first thing we want to undo. Addition is the inverse of subtraction, so I'm going to add 5 to both sides. I'm also going to write my expression, instead of 4x divided by 3, I'm going to write it in its equivalent form of 4/3 x equals 11 plus 5 is 16. The reason I'm going to do this is I'm going to save myself a step in the process. I can multiply 4/3 times its multiplicative inverse, also known as its reciprocal, 3/4. 3 times 4 is 12, 4 times 3 is 12. That simplifies to 1, which is really the number we want to get in front of our variable. So I'm going to multiply the 16 by 3/4 as well. So I'm going to have x equals, and this is how I'm going to multiply. 16 times 3 is 48. 48 divided by 4 is 12. So x equals 12. Again, number 4 is a literal equation. It looks very similar to number 3, it's just that the term with the 5y, we need to think of the 5y as being its own value. Those two are going to stay together because what we're trying to split up are the 4 and the x. So just like on number 3, I'm going to start by doing the addition, but this time it's adding 5y, which we know is not a like term with the 11. So now I'm left with 4/3 x equals 11 plus 5y. I'm going to multiply by the reciprocal, just like I did on number 3. Keep in mind, 11 plus 5y represents a single value, so we're taking this entire value times 3/4. So we could write this as x equals 3/4 times 11 plus 5y, or we can distribute the 3/4. Take the 3/4 times the 11, the 3/4 times the 5y, and we will have 3 times 11 is 33 over 4. 3 times 5y is 15y over 4. And if I could, I would simplify each fraction, but in this instance, I cannot. Here we have some more. Again, the directions are solve for x. So if I take a look at number 5, the first thing that is being done to x is that we are adding 3, and after it's been added, it gets multiplied by 2/5. So just like we did on numbers 3 and 4, I'm going to multiply by the reciprocal. So now I have x plus 3 equals, multiply 6 with 5, that's 30, and divide that by 2, which is 15. Then we have x plus 3. We can do the inverse of adding 3, and that's subtract 3. And we are left with x equals 12. Now, just like on the previous slide, the following literal equation, very similar to the first linear equation. This one, we've replaced the 3 with y, so everything really is going to be just the same. We're just going to have some terms that we can't combine. So again, start by multiplying by the reciprocal of 2/5, which is 5/2. That leaves us with x plus y equals, and again, I'm going to take the 6 times the 5, which is 30, divide by 2 is 15, and we want to isolate the x. We want to get x by itself, so we need to do the inverse of add, and that's subtract y, but 15 and y are not like terms. So this answer is x equals 15 minus y. Number 7. We could go ahead and distribute. I'm also going to point out that if I look at this side, I could undo the divide by 2, or multiply by 2, excuse me, by dividing both sides by 2. It really doesn't matter. If we were to divide both sides by 2, I would divide both the 4x and the 12 by 2. And the only reason I would suggest dividing by 2 rather than distributing it is because it gives us a simpler equation to work with. It simplifies the values we have on the right side while also undoing this multiplication. So we could use the 2 would be canceled out, excuse me. The 2 would cancel on that left side. So we're left with 3x plus 4 equal to 4x divided by 2 is 2x. 12 divided by 2 is 6. Should you decide you want to distribute instead, you would work with 6x plus 4. Oops, excuse me, I have to do 2 times 4. 2 times 3 is 6x, 2 times 4 is 8, equal to 4x plus 12. We only have to distribute on the left side. It doesn't matter which method you're using. The next steps are pretty much going to be the same. I always recommend getting the variable on one side. And since they're both positive, I'm going to undo the smaller of the two of them. So I'm going to subtract 2x from each side first. So that gives me a 1x, or just x, plus 4 equals 6. So now I just need the inverse of plus 4, and that's minus 4. And I have x equals 2. I'm going to do the same thing on the one where I distributed. I'm going to subtract the smaller of my two x terms. So I end up with 2x plus 8 equals 12. 2 times x and then add 8, so that means I need to subtract the 8 first, because that's the inverse of plus 8. And we have 2x equals 4. And then I can do the inverse of the multiply by 2 by dividing by 2. And you'll see I get the same answer as when I divided by 2 to begin with. I get x equals 2. So it's really just your preference when you have a situation where you could divide by that value that's in front of the expression. that it would be multiplied with, or you could distribute. It really does not matter. I am going to go ahead and use the divide by 2 on my number 8 here. Again, everything looks alike except it's 4y and 12y, where before they were just constants. So remember, the 4y and the 12y are values of themselves. What we're working on is getting the x by itself. So I'm going to start by dividing both sides by 2, and I'm going to have 3x plus 4y, because dividing by 2 is the inverse of that multiplication, equals, now I know I wrote the division different on the right side here than I did on number 7, but I'm going to do the same thing. I'm going to divide both of these by 2. So 4x divided by 2 is 2x. Oh, I forgot my y on my 4. And then 12y divided by 2 is 6y. Now remember, 4y and 6y are values that are just going to stay with those y's. Just like I did on number 7, I'm going to do the inverse of the smaller positive x term. So that's going to be a subtract 2x, which gives me x on the left side plus 4y equal to 6y. Now to isolate x, I want to do the inverse of the addition. So I subtract 4y, and I have x equals 2y. So very similar to what we had on number 7. I have one more literal equation to do with you, and it's one where everything is a variable. So I'm going to look at this, and I'm solving for x. So the first operation on x, here, I'm going to set up a table like this. Operation on x, and then the steps for solving. So the operation on x, the first thing that's happening is multiply by a. The second thing that's happening is add b. So we have a times x plus b. The third thing that is happening is divide by c. And the fourth thing that is happening is the subtract d. When I solve this, I want to go in the reverse order. So the first thing I'm going to do is add d. To undo the division, I'm going to multiply by c. To undo the addition, I'm going to subtract b. And then to undo the multiplication by a, I divide by a. So let's see what this looks like. We said for solving, the first thing we would do is add the d. So if I add d on both sides, I have ax plus b divided by c equals e plus d. Then I need to multiply by c, so I multiply both sides by c keeping in mind that E plus D is a value that gets multiplied with C. So we have AX plus B equals, you could distribute the C, or you could just write it as C times E plus D. Either one is fine. Third step, we said we would subtract B. Keep in mind, we haven't had any terms that we can actually combine or simplify. That's why I just keep writing with parentheses, and I don't change any of my variables. So now I've subtracted B from both sides, and finally divide by A. And that is that entire expression on the right side is divided by A. So X is equal to C times E plus D, subtract B over A. If you did go ahead and distribute the C, you would have C times E plus C times D minus B, and all of that is over A. Either one of these expressions is correct. And this includes our video on multi-step equations and literal equations.